Hey everyone, thank you for coming to my talk. I'm going to talk about Scala and tools for product development, or tools for Scala startups. Quick question for you. How many of you have heard about Rock the JVM? Can you raise your hands? Beautiful. Thank you so much for following my work. For anyone who was watching this on another platform, maybe on YouTube or something, my name is Daniel Ciocărlan. I'm a Romanian software engineer, and I created this website called Rock the JVM, where I teach pretty much everything in the Scala ecosystem, including various tools and libraries and techniques for functional programming and product development. My courses have reached more than 100,000 people all over the world, and I've also had the privilege of training high-performance teams at some big names that you may have heard about, including Adobe, Apple, and other big companies. And my website is rockthejvm.com, where you can find pretty much everything that I've put out. I've recorded hundreds of hours of video courses and compressed lessons on the best practices in functional programming and in the Scala ecosystem. And you can find my work at rockthejvm.com. You can email me at that email, daniel@rockthejvm.com, for pretty much anything about Scala. You can find me at rockthejvm.com on Twitter and LinkedIn and Reddit and YouTube and pretty much all socials. All right. So I'm going to talk about startups, and I'm going to talk about product development in particular, because startup is a very loaded term. So I'm going to talk about mostly products. And the question is, why would you build a startup? A startup means different things to different people. And so I would categorize startups depending on the objective that you set for yourself. A startup may mean a single product that you've built as a single person. A startup may mean a unicorn that it wants to reach out millions and billions of people, reach out to IPOs and stuff, and make trillions of dollars and make you a gazillionaire. So startup can mean different things. But some reasons that resonate with me include something like this: to build a product that you can be proud of, build a product as a single developer, or create a lifestyle business that is sustainable and gets you a decent income, enough to free up your time to spend the time on the activities that you like, or learn some skills that you would have liked but never had the time for, or speak at conferences, or enjoyable things like that, or to make something sustainable as a product, either by yourself or as a small team. So you can have this sort of camaraderie where you can reach out to 2 or 3 of your friends and build a product that serves a decent amount of people and has a minimal impact on the world. Or if you want to build a rocket ship that scales up to billions of people and makes trillions of dollars, you can also do that. So this is one potential reason why I would build what I call a startup, depending on the kind of objective that you set for yourself. Now, in order to build something that's technical, so a startup in the sense of a digital product or software system, you have at your disposal a variety of tools and technologies, mostly in the Python ecosystem, mostly in the JavaScript ecosystem, and maybe some other languages like in Rails or in TypeScript or in Java, like you have Spring and stuff. I would argue that Scala is well suited for startups at any scale, which is why I would put Scala on top of pretty much everything else, because it's such a productive language. So you can build your own products with Scala for any scale and for any purpose. This is what I would like to talk about in this presentation, and primarily what I want to talk about is some tools that you can use as a software engineer to build products at any scale, and also what we can do to target Scala as a language for product development, not necessarily a language for, or not necessarily only as a language for software engineering and computer science research. All right, so I'm going to talk about tools that you can use as a software engineer, and then I'm going to, hopefully, by the end of this presentation, start a conversation of what it means to be productive as a software engineer and how we can leverage Scala as the ultimate tool to doing that. So why would you build a Scala startup? Well, it means to me that Scala is a truly scalable language, because you can stay in the same ecosystem regardless of whether you're building a one-line script or whether you're building a million lines of code, building something that serves millions of people or processes exabytes of data at scale or whatever you have. So you can ship an MVP, but still stay in the same ecosystem because you can iterate and expand your code as necessary. Scala is, as I'm pretty sure you can attest on your own experience, that's I'm guessing why you're here, is because of your love for Scala, because it's so beautiful, it's so concise, it's so expressive, it's so powerful, and its type safety is almost unparalleled. And it allows you to do a lot of productivity with very little code and with very little let's say, labor in terms of code that you have to write. And so Scala is, in my opinion, a very powerful tool, very underrated for product development in a full stack setting. And full stack because Scala is also multi-platform in the sense that you can build backend systems, which I'm pretty sure most of you have experience with, but you can also build front ends, and you can build very scalable front ends by leveraging very simple principles that you can expand in reactive UIs. And it's also been battle tested in very big systems all over the world, including Twitter and Disney and Databricks, and we have many examples of various tools that have proven themselves in production. So can Scala do it? My answer is a resounding yes. And the caveat to that is that you need to know the lay of the land, which is one of the goals of this presentation. So in terms of a Scala tech stack, we have some things to keep in mind in order to build a powerful and an effective tech stack. So what makes a good tech stack? First of all, you need to be able to have the entire tech stack in your head, which is something that very few libraries in the Scala world have managed to do, or they have managed to do only to very experienced engineers. So if you're someone very experienced with, for example, the type level stack, you can have the entire tech stack in your head, but only after several years of experience. One of my jobs at Rock the JVM has been to lower down that learning curve and make the core principles easy to remember and easy to keep in your mind. So ideally, you should be able to work on a plane with no internet connection. That's before Elon Musk can get Starlinks on every plane. To work in a plane with just the documentation of the code of the library and still be able to write your code as you have no internet connection or no ChatGPT or no Googles or no Stack Overflows. So if you have the entire framework in your head, I see that as a sign of success. Then a tech stack needs to be performant because no full stack product is ever going to be useful unless it moves quite quickly. It also needs to be scalable in order for us to build products for a variety of audiences and for small or big user bases. Then we need to have something that's, let's say, underserved in pretty much all of software development, really, which is the ease of deployment. There have been many attempts at simplifying deployment and shipping products, and Scala is no stranger to the, let's say, the overhead in managing scripts and deployment stuff that we need to manage ourselves. And so if you have a good tech stack, you should be able to do like a Control-K or Control-Shift-KW or whatever, and it should like push to production. I'm not sure why you would need anything more complicated than that. And obviously the developer experience is something that is going to help us a lot because I'm seeing no objective reason why a skilled Scala developer couldn't be able to ship a full-blown, full-stack product with like credit card checkout and stuff in 3 days or in 3 hours, for that matter. So the dev experience needs to be conducive to that sort of experience. And obviously, we have some additional things that will make a tech stack usable and friendly, which means the compatibility with other tools so that you can integrate yourself very easily, and also the ecosystem maturity and community support, which allows us to solve each other's problems and help each other along the way. Now, for me, I am a solo engineer. So I'm building products for myself, so I don't care about best practices. Although I happen to have good knowledge over them, I will pick the best practice for me because I'm the one writing the code, I'm the one reading it later, and I'm the one who's going to maintain them. So if you're a solo developer, my advice is just to make up your own best practice so that you don't hit yourself in the head later. If you're a small team, again, you need to make your own best practice by talking to each other and filling up each other's gaps. And only if you're a big team or if you need to introduce process along the way, only then it's worth establishing something more, let's say, elaborate or something more process-oriented. Now, in what I'm going to talk about next, I'm going to outline some tech stacks and some tools for product development that will help you build Scala products if you combine them together. With a caveat and with a disclaimer that I am a complete ignorant about the state of many libraries and tools. You're probably going to ask, what about this library? Or what about that library? You haven't talked about that. I will very much like to know about that. So I'm about to show you some things that work for me. I'm pretty sure there are some very useful tools out there, and I want to know about them. And you should also do your best to speak about them at conferences like this, or on, I don't know, in blog posts or in YouTube channels. I'm personally offering my own YouTube channel to help evangelize your library or your tool if you need. So if you have this sort of request, I'm more than happy to offer my own channel to do that. Now, what I will also say is that Scala is an extremely underrated language, which is probably what you've also seen. Compared to the likes of JavaScript or Python, Scala is super underrated. And if you have, for example, let's say, 5% or 10% of the workload and of the, let's say, dev time invested into Scala compared to the dev time in JavaScript, Scala would probably destroy them outright. I'm going to talk about some tools and some tech stacks that worked for me, and you can pick and choose whatever you find most suitable for your own mindset. Okay, so the first backend Scala tool that I'm going to talk about is the Akka or Peko stack. You probably have experience with Akka. It's one of the oldest toolkits in the true sense of the word, and it involves the actor model that has proven itself in production many, many times and over many years. Now, obviously, Akka has changed their license to something business-oriented, which is why we have this Peko thing, which is just as good as Akka, and it's also an Apache top-level project, which means that it has good support, it has good maintenance, it has active contributions, and it has great interoperability with other tools or other stacks, for example, Akka or Cassandra or Postgres or things of that sort. So if you want to use this sort of stack, this is the kind of combination that I would personally use. I'm working on a product right now, and I'm going to use Peko for it, which involves Peko HTTP for a nice DSL to create web services or microservices, Peko Streams for data flow, and Peko Streams has this very nice graph DSL that allows you to see your data flow almost visually. It's like an ASCII art that compiles in Scala. Then we have, for storage, Peko Persistence and this CQRS pattern, which allows you to separate the act of emission of commands from the act of reading events, which is far more useful to the user to understand, not necessarily in terms of the clicks that they used in the application. And for scalability, if you have a single service or a business logic that cannot really stay on the same machine, there's also the option of clustering that, which is a very powerful tool. And if you want microservices to talk to each other, you have Peko gRPC. And we have other libraries like Peko interacting with Kafka or Postgres or Cassandra or other kinds of services. Now, Akka or Peko, this stack, is best used for systems that are based on events. So maybe something that tracks orders in an e-commerce store or in my little product that may, or by the way, it may or may not see the light of day. I don't know, but if it's good, you're probably going to hear about it with I don't know, something authenticated or some user data capture or new data arriving in a system or something like that. So PECO is very useful for systems that are based on events, and you can obtain scalability by multiplying instances of the same type. For example, you can multiply a little microservice, or you can multiply even a single core of business logic with clustering. So that's one tech stack. Another tech stack is the Zio stack. Some of the talks here today have touched upon Zio at least. And Zio is, I'm pretty sure you know, this is an effect system that uses pure functional programming, and it's also been proven in production. If you were to choose the Zio stack, this is the kind of library combination that I would use. Zio HTTP with Zio JSON. If you want to use GraphQL, there's Caliban for doing that. It's an amazing little library. For data flows, we have Zio streams. For business logic, we have arbitrary effects described as core Zio data types. Then we have, for storage, we have Quill and the new library Magnum. There's also a form of Zio SQL. And pretty much for everything else, Zio has an increasingly rich ecosystem of libraries that can interact Zio with various other services like Zio Kafka, Zio whatever. And if you wanted to use the stack, I would pick Zio for type safety and for effect-based backend systems, and for bringing or for purifying other Java code and bringing them into the same ecosystem. So that's the Zio stack. Obviously, we have the type level stack as well. These are two equivalent ecosystems. Type level is a little bit more general and a little bit more mathematical in that sense. So the type level stack is based on Cat's effect, and this is the effect system with pure functional programming as well. This has had the chance over the years to be proven in slightly bigger systems like Disney streaming. And if you were to choose this stack, these are the libraries that I would use. HTTP4S, which even though HTTP4S is at 0.37 for the past 5 years. It has proven them in production many, many times over, so it might as well be a good 1.0. We have FS2, and we have some fans here for FS2 that can treat data flows easily. For the business logic, we have various effect systems that you can plug in. Cat's effect is obviously the core choice, but you also have Monix, or you can even plug in the Zio scheduler, the Zio type in the type level stack, as well as you use the so-called tagless final. And for everything else, you can purify other Java libraries, or you can have other libraries in the type level ecosystem for building various use cases. This is best for bigger projects if you want to have something that uses I don't know, something more critical, or a banking system, or a streaming service where a lot of people would lose a lot of money if the system went down. Then you would use something like this. And if you want to keep the code mathematically provably correct, you would use something like this. Now, this is a new slide that I've added this morning because we have had a talk with Kio. So Kio is this new effect system with a direct style toolkit. Kio is still in active development, so I can't really recommend it for production use cases at the moment. But it's great for experimental projects, and you can use for web services. We have Kio Tapier and Kio Caliban. If you want to use GraphQL, you have Kio Core, or the Kio algebraic, I forget what it's called. It's Kio Prelude, right? Kio Prelude for functional programming. And the tight integration with Zio gives it access to the Zio ecosystem, which is going to make it potentially great for backend systems. So these are library stacks. Then we have full frameworks. Has anyone forgotten about Play? So Play framework has been one of the oldest and still in active development true Scala frameworks. So it's a framework in the true sense of the word, because we have batteries included. So there's very little that you need to integrate with Play Framework. You can simply use the business logic in core Scala, or if you want, you can use Akka or Peko because Play Framework is built with Akka or Peko. So Play supports Scala 3. It's still in active development, and it's great for building scalable web applications. And I personally know institutions that are using Play Framework. I recently did a training session for a group of Scala developers that would work for HMRC in the UK. So the HMRC tax system in the UK, at least the web application for submitting tax returns, is based on Play Framework. So it's great for creating stable and robust web applications, especially if you want to scale out. And then we have Howie. Is Howie in the room? No. So Howie is great. Howie is one of the Scala engineers in the community that I respect the most because he single-handedly has an entire stack for building Scala applications of any shape and size. So with pure Scala, you can build pretty much anything with his libraries. And one reason why I respect Howie so much is because he also has his own skin in the game. He uses his own libraries to build his own products. He worked at Databricks for a while. I'm pretty sure he used some of these libraries there as well. He created his own book. I might be wrong about this, but I'm pretty sure that he published his own book with the libraries that I'm showing here. So we have Cask, Scala tags. You can also do server-side rendering. You can do Scala.js with his libraries. So you can pretty much build a full-blown Scala product with some of Howie's libraries. This is great for solo developers or people jumping into Scala because you don't need that complicated let's say, notions about effect systems or advanced functional programming, higher kind of types, implicits, or whatever. You can get started building products very quickly. So these are some of the stacks for backend. Some of these tools also have libraries compiled for frontend. Speaking of which, Scala.js is great. We should talk more at JavaScript conferences about Scala.js. Even though we compile the JavaScript binaries to like megabytes in size, which is probably going to make JavaScript developers sneer at us, the thinking model behind reactive libraries and behind reactive web applications in Scala.js make it very easy for us to build highly scalable UIs. And the two libraries that I personally used for my own products are Tyrian and Laminar. Has anyone heard about Tyrian? Can you raise your hands? Okay, so Tyrian is a great Scala.js library that has the architecture inspired by Elm, and this is based on Cat's effect, and it has pure functional programming, and you can learn that in 1.5 hours. You can get all the principles of Tyrian, and then you can write reactive web applications with all the concepts that you need. So it works best with a type level stack. I personally teach this in my giant type level rite of passage course, and it works great for reactive web applications. The other one is Laminar. How many of you have heard about Laminar? All right, a little bit more. So Laminar is a functional reactive programming UI library, and it works with pretty much any backend stack. Again, Nikita, who wrote Laminar, is a developer that I respect a lot because with just 2 libraries and with maybe 2 hours of learning time, you can create arbitrarily complex web applications with Scala.js. And Scala.js is great because it's extremely stable and it allows us to interact with the JavaScript ecosystem. So much the same in the same style as regular Scala can leverage the JVM ecosystem, Scala.js can leverage the JavaScript ecosystem. And we have tools for interacting with the TypeScript ecosystem. I think we're going to hear Olivier talking later about his scaffolding with the Zio full stack application, and he used scalably typed to use a TypeScript library, and very easily so with Scala.js. Now, we have back-end Scala tools, we have front-end Scala tools, and that is strictly for software development, for like writing code. But we also have other tools that are going to be very helpful for us to build and ship our code. For me, as a solo developer, I shouldn't really care about build systems, DevOps, and things like that. Ideally, these build systems would allow me to hit a command like Control-Shift something and just push the code to a branch and then deploy to production in another click if that thing works well. So we have many definition libraries for cross-platform development. So sharing code between front-end and back-end is one of the let's say, unsung heroes in Scala full stack development, and it's an extremely underrated feature that will help developers free up their mental space a lot. For example, if you're trying to do a full stack web application with Spring and then React on the front end, you'll need to do type definitions on TypeScript or something so that you can use the services in React. And then you'll have to rebuild these things whenever you change your data model. With Scala, you don't need to do that. So with these definition libraries like Tapir and Smithy4S and various other libraries for data definition, you don't have to rebuild your data model between the backend and the front end. We can consider Scala as a completely full stack language, which I think is completely underrated and would help accelerate the development of full stack products. Then we have build systems like SBT and Mill. Again, we have to thank Eugene for essentially holding 3/4 of all Scala products on his shoulders by developing SBT. So huge claps to Eugene for doing that. Most of the rest goes to Howie for developing the Mill system, and we have Jamie to talk about the porting of Mill to Scala 3, which is absolutely fantastic. I'm looking forward to doing that. So these build systems are super powerful, and it would be great if they allowed us to develop really short commands to push and deploy our code. Then we have dev tools like Metals and IntelliJ, which have been improving over time. With Scala 3, we have increasing support for various language features and increasing the dev experience. And we have various things that I really don't want to talk about. I know very little about deployment. Ideally, I would prefer to ship my code to a regular VPS like DigitalOcean and stuff and not care about pretty much anything else. But you have these at your disposal, and it would be great to have tools or libraries that would push to these systems automatically. All right, so this is the disclaimer. If you know your own tool that works better, I would very much like to know about it. Like I said, I'm ignorant about anything that I haven't tried, so this thing may very easily hold true. Now, I've talked about various tools and various library stacks that work well in a full stack setting. But they're mostly library stacks. We only have Play Framework as a full framework for building applications. So the question is, where are the rest of the Scala frameworks? Because Scala is so powerful that it allows us to perform any sort of task. And it's very powerful in the sense that you can build arbitrarily large applications. So where are the frameworks for doing that? That's a question that I will talk about and expand later, but this is just food for thought. Now, I've talked about software development, writing code, and maybe building and deploying your code to production. It would be absolutely great if we could somehow integrate these tighter, and I'm personally going to help test this on my own with my own products and maybe share my lessons along the way so that we can have let's say, a shortcut to building Scala products quickly in like a day or two, rather than in a month or two. Now, speaking about the tools for software development, it's not just about writing code, but integrating with other services, because a startup is not just the product implementation or the code that you write and that you push to production, and congratulations, you have your own JVM application at 172.55.42.1. You need to integrate yourself with other products to be a useful thing for the world. And so you need to be able to integrate your own product with other tools. For example, analytics or alerting or emails or AI or community support or customer service. These are all important components of a successful startup, and for now, we need to essentially write our own tools to be able to integrate to these, or hack our way through integrating maybe a Scala.js script that does social proof and integrates intercom as a little bubble here in your front-end application. But it's mostly hacked. And so it would be great if we had better tools or a tighter integration with some of these services so that we can deploy products that are immediately useful by leveraging these other services. Now, speaking about the dev cycle, this is also something that we could potentially improve. Ideally, we would have the development cycle fun, and Scala is plenty fun on its own right. It's a beautiful language, it's very expressive, it's very powerful. But what about the dev cycle and the developer experience? Because we get errors, we get compiling things that don't work our way, we have very cryptic errors sometimes. So it would be very cool if we could iterate our products very quickly and get errors and get instructions on how to solve them very clearly so that we can progress on our code. So the goal for a good toolkit would be something like this, to offer clear errors, to offer easy deployment, speaking of build systems, integrate easily with other services. So these are all areas where especially build systems could potentially help in creating products very quickly. Now, speaking of the dev cycle, I like to think about the dev cycle as something that we don't necessarily do over a weekend, but something that we do continuously for years or maybe our entire careers. So it's not a thing that you do once, but developing a product or the mindset of developing a product is something that's habitual. It's a habit. And so like any habit, I like to think about habits in terms of this little book that was a cornerstone for how I personally organize my own habits. It's called Atomic Habits. And the 4 critical tenets of creating a good habit, or the opposites of that, breaking a bad habit, would be to make the activity obvious, make it attractive, make it easy, and make it satisfying. If you maximize these 4 metrics, the habit loop becomes effortless and becomes very cool, very fun, and very easy to repeat. It brings a virtuous cycle. And specifically about the dev cycle, if we could create a toolkit that would enforce, or rather encourage, these tenets, we would have a really cool dev cycle and would make adoption of Scala really easy. Now, concretely, what does that mean? In terms of make it obvious, if you could build a toolkit or a framework that makes it super clear what you're allowed to do where you should put your code, that would very much relieve mental burden in terms of decision making. If you can make it attractive, the vision of your product needs to be compelling. So you'd be able to, if you are somehow able to describe your vision of your product in code very easily, so that the framework can guide you over where you need to add your code, that would be absolutely fantastic. Scala does most of the job in tenet number 3, which makes it easy because if you know even a minimum of Scala, you can translate your thoughts very easily into succinct code. So you can do a lot with very little code. But in terms of tools for product development, it would be absolutely fantastic if we could make local iteration and the building of a testable product very easy. So maybe a shortcut or something that would trigger an SBT build so that we can ship to a branch or ship to a staging environment so that we can test our product. And finally, make it satisfying. The code is mostly beautiful in Scala, unless you write Java code with Scala syntax, which all of us are trying to avoid. But the satisfying part is knowing that a product is great and also that the code is beautiful on the inside. It's like building a Mac, right? So we have Steve Jobs, very famous for saying that a well-engineered product should be beautiful on the outside, and it should be beautiful on the inside too. So when you open the screws in a Mac, it's absolutely impeccable. So it would be absolutely fantastic if we could do something like that for Scala as well. Now, finally, if you were to build a startup or a product, the most important thing is not necessarily the code. It's picking the relevant problems to solve. So as much as possible, try to be useful and solving pain points that you hear about it, starting with your own. So this is what I am personally trying to do over the next span of time, and I'm going to help as much as I can move the needle in that direction. So at this point, I've talked about tools for product development, but you may be wondering what's the point of that? One of the points was to create a 10,000 view over the land of libraries, and I'm very open to hearing suggestions of other tools that you found useful. But primarily for this talk, I wanted to start a conversation because Scala is an incredibly powerful language. It's an incredibly powerful toolkit, and it's not just for building distributed systems that have worked at the scales of Twitter and Databricks and PayPal and whatever else Scala has managed to build, but it's a very powerful language for building simple and then expandable products quickly. So far, Scala has not, at least in my mind, has had this objective as a target, but my question to you and my question to this conversation would be, what do we want Scala to be? Do we want Scala to be this research language that in 3 years' time Java is going to start stealing features from? Or do we want Scala to be a product language that would help rival the JavaScript frameworks and build products in a day instead of a week? All right. So this is the kind of conversation that I want to start. I hope I was at least giving some food for thought. And speaking of Scala products, we have a workshop tomorrow, and I invite all of you to join. We're going to build a full stack product live, almost from scratch. And by the end of the workshop tomorrow, we're going to have something deployed with credit card checkout, hopefully. So somebody can pay for the product that we're building. Hopefully I can do that in like 5 hours. We'll see. So I invite everyone to join the workshop tomorrow. I am more than happy to have you there. Scala is a great language, and I'm pretty sure that you agree. If you have any questions, I'm more than happy to help answer them. You can find my work at Rock the JVM. Thank you so much. Going once.
Thank you, Gustav. And this morning there was the idea that there are many ways of doing Scala, and you showed a number of them. Do you think it's a problem to have so many ways of building stacks in Scala?
I think I see these alternative stacks as I don't think that this is a bad thing. So as Valentin was saying in the beginning, look at the JavaScript frameworks. So you have like React and Astra and Svelte and Vue and whatever. So there are many ways of doing the same thing, but they're not necessarily ways of doing the same thing, but rather different mindsets, different approaches, different mental models. And I view that as great because these mental models are not easily transferable to other ecosystems. So I think it's great, and I think it's creating rather a moat around Scala as something that differentiates Scala compared to other languages.
Thank you very much.
Thank you so much.